Yeah, it's recording now. Okay. So this is our computer vision project, which we're about to present to you guys. My name is Marcel Vodmia.
And I'm Barbara Namulwana.
So today we're going to be presenting to you guys our computer vision project, which is object and digit classification using HOG features. And in this project, we're going to be using a MATLAB software program to analyze and demonstrate how we can use HOG to classify digits and objects.
So, just to give you a brief background about HOG, HOG in full is a histogram of oriented gradient. Well, this was first proposed by Dalal and Triggs. Basically, their main reason for this was for human body detection, but as innovation keeps going and invention, HOG has been applied further and it's now been successful and popular in descriptors in computer vision and pattern recognition. Like also what we are doing in this project presentation will be considered as pattern recognition. So that shows you one of how HOG has evolved and developed. Also more on HOG, it counts occurrence of graduate orientation in a part of an image, and thus more of the appearance descriptor. So as you may know how it applied on an image, it splits up the image into different patterns, and as a way of identifying it more or extracting it more. And in that, it divides the image into those small cells and then computes each histogram of gradient directions or edge directions based on the central differences of the image.
So some basic problems that have been solved using computer vision, which we're also gonna analyze, will be like house numbers. We're gonna try to see how we can go through use HOGs to identify house numbers in various apartment buildings. Also, we're gonna conduct a study on how we can use HOG to classify printed digit on printed documents, and we're also going to be looking into how HOG can be used to classify handwritten documents and license number plate. So this is looking into some of the problems that we can solve using HOG and with our knowledge of computer vision.
Should I go ahead? Well, the problems that we'll be addressing include recognizing characters in images that have been extensively studied for lots and lots of years. Also, furthermore, on scanned documents, we'll be studying them in context. And also another issue would be handwriting, and that's also one of the disturbing things or troubling things where HOG has been applied. Also, the fact of classifying objects, say already mentioned, house numbers and license plates. And the other would be recognizing widely. HOG has been recognized widely in the industry and also academics. Like we covered it in class, it's used to identify a number of objects and digits in handwritten and scanned documents.
So for this project, for this presentation, we're going to focus on two studies. The first one is going to be numeric digit. So under the numeric digit, like we talked earlier in the previous slide, we're going to take you guys through how we can classify handwritten digit using HOG, how we can classify like scanned documents, like digit on scanned documents using HOGs, and also we're gonna take you guys through how we can classify like not license number plate, like the various digits on license number plate using HOG. Then the second study which we're going to be conducting will be like how we can classify object using HOGs. So those like the two basic methods that we're going to be using for this project, and that's what we're going to be analyzing using HOGs. So before we get into our studies, there were some few videos we found online which we think is going to like grab your attention on what we're about to present to you guys. So we're just going to try to play the video so you guys like kind of see what we're talking about, and we're going to like explain after the video. So let me try to play the first one. Let's give it some time. Let me see. So in this video, actually what's going on is like you're using HOGs to classify objects. So the sport car, as you can see, it's moving, and it can classify like all the cones on the road. And this is like the point of view is like from the driver's mirror, or from the like it's like a camera from the sport car that you can classify like the objects that are on the way and the obstacles, and how the car can like escape from those obstacles. And this takes us to like the point of automated vehicles that you can drive without any person controlling them. So you can just set like an HOG feature in it, and you can like drive and be able to like identify objects and escape those objects without bumping into them.
Well, as you can see, the driver doesn't hit no cones. He avoids all the cones on the road and is tracing a path. Also, this feature, as we can see, can be also used in map reading. Say people that take road trips, it can be applied in, is it GPS? Yeah,
GPS.
So to tell where the obstacles are on the road as somebody drives through, and avoid the obstacles, and also what routes to take, and so that they can arrive at their destination.
So we have this other video which we're gonna try to like play it for you guys.
Go to the slide. Onto the slide. So in our second video, it was basically a car identification video. So in that video, you can see how they can be able to, they're identifying specific cars, and in some of the car objects that are being identified, they can identify also, they draw, say, a square feature on the license plate. So it shows you more how HOG feature extraction can be used on toll roads, say, to get the number of vehicles that are going through, or or in case any, say, a vehicle runs a red light, it can be tracked with the license plates. So yeah, that's also an addition to the video. And then on our next slide, we should go with that.
So now, after watching the video, at least now I believe you guys have an idea of what we're talking about, the HOG classification, which is what we saw in the video. So now we're going to start by taking you guys through the process that we can use to, like, the procedure that we can use to classify, like, object using HOGs. So for the first object, you're going to, like, have samples of points, like X points, for your training data of the objects that you want to, like, dictate. So these points basically are like points that you want to, like the cars that you want to view, because using HOGs, you can classify any kind of object. For example, in our case study, we use just vehicles. You can also classify, like, other objects. So the objects that you want to classify will be like the samples of X. Then also, the second step is that you're going to have, like, classification of data that you don't want to view. Those will be like the Y samples from your training set. There'll be, like, points that you don't want to view. Then you're going to use, like, the HOG extractor for those samples. And when you're doing that, you're going to understand that in practice, the samples of, like, the Y samples, the samples that you don't want to see, has to be, like, greater than the samples that you want to view.
So after, like, sampling the future, after sampling your data, the next step would be training a linear support vector machine. So this linear support vector machine is kind of like is sort of like a classifier that you are feeding in, so that it's ready to tell what features it will be extracting, or what features you, on the sample point, what features you would need to be extracted using HOG features. And then, so when you go to the fourth point after training the vector machine, our fourth procedure, so those positive X samples that you extracted, so you would get them and kind of sort them in, like, a hierarchy or a probability of what is considered first. And then, so when you have now only the X positive samples in that hierarchy of probability or confidence, you still retrain that classifier, the vector machine, using those now samples without the negative samples, just the positive samples that you need to extract using HOG features. And after that procedure, what your fifth procedure is now, after training and retraining the classifier, you're confident that it can work and help with extracting using HOG features the objects. So at the fifth step, you're sure that it's gonna work and it's gonna be able to classify for you the objects that you need. And also covering our next topic of digit classification, still using HOG features. In this, there is also a number of steps that you follow during digit classification, and there are 3 steps. And the first one is pre-processing of input acquired from either a capturing device, say a camera, or taken from a database. So this pre-processing step is basically a series of operations performed on the MNIST handwritten numeric digits, say from a database. These MNIST handwritten digits they are known to be like 400 digits. So in this preprocessing states, they are bettered or enhanced. So this preprocessing state enhances that image of handwritten digits that you have and makes them suitable for our next step of segmentation. So in the preprocessing, it enhances getting them ready for segmentation, and in the segmentation state, now that enhanced image is decomposed, and also like how segmentation is literally known, the image is decomposed and split into sub-images of an individual character in the segmentation state. So in this state, that image that has been decomposed is like isolated by assigning it a specific dimension, so that it's the one that's tackled in the HOG feature extraction. And after the pre-processing stage of image enhancement and segmentation, next would be feature extraction to uniquely represent an individual digit. So after a digit has been segmented or split into, now it's brought to the feature extraction stage, and in this stage the features of the numeric digits that are crucial for classifying at a recognition stage are extracted. So if we draw you back to what we mentioned about getting samples, this would be our positive samples that we need to extract. So they are the samples that are used in this feature extraction stage, and this is mainly one of the most important stages and also effective stages, because in this stage you're getting the features that you will need, not the negative samples anymore, but the positive samples that are needed for classification. So in this stage you need to really take care of the exact features that you want, so that you reduce any misclarification, coincidences, or circumstances that may occur. And after the feature extraction stage, we go into the third and the last stage, which is classifying the extracted features using HOG. Yeah, that's about digit classification.
So on the next slide, what we're going to be doing will be based on the procedures that we explained earlier. So now on figure 1, it's a sample of a handwritten digit. It's like our samples of eggs that we've classified, So for us now, we're going to apply like the HOG feature on this data, and when we apply the HOG feature on this data, we're gonna follow this procedure. The first procedure we're gonna follow is that we're gonna acquire a label of data set with image of object, which is like the figure 1 we showed you above in the previous slides. Then when we take this data, what we're gonna do is that when we apply the HOG feature on it, we're gonna partition the data into set, and those sets we're gonna call them the training set and the test set. Then now to the train classifier, we're going to use the feature extractions from the training set. Then when we do that, we're going to apply the tested classifier using the feature extracted from the test set. Then when we do that, we're going to have a figure like this. On your left, that's going to be what we'll have using the HOG feature. And as we said earlier, the software we're using is a MATLAB, which we're going to sample all this data into them and use the HOG feature to have our extraction. So this is just like a sample of a digit object, a handwritten digit, which we're trying to classify using the HOG feature. So this is like a sample of our MATLAB code, which we're going to try to like run it through our MATLAB. And when we run the code through our MATLAB, we're gonna have this feature, and the 1, 3, and 8. Those are the particular features that we choose to classify. As we said, we have like samples of X data, which were the features we want to classify. So those X data will be 1, 3, and 8. So in this case, you can want to classify any kind of digit, so you just have to like declare them to be like your set of X data. Then for the other figures that we don't want to see, those are the data that we classify as our Y figures. So when we run this through the MATLAB code, we're going to have this. And unfortunately, this is the second video we're doing, because the first video, the voice was not really clear, so we can't really run the code because it's on the other laptop.
Yeah, and so the figure you see on the right, so you can see some of the figures that are beside 2 are excluded in the segmentation process of HOG extraction. Well, that shows you those would be our negative samples, the samples that we don't need. So those would be our Y's and 2 would be our X. That's why you see 2 is now extracted using HOG futures, and you can see the different segments, how 2 gets drawn out. Yeah, that's more an addition of what was on the previous slides. Still on the left you see an extraction of 3, and on the right you see still segments or small cells drawing out a figure of 2. If you're critical enough, you can see that in the images, in the 3 images on the right.
So what was some of the applications of the HOG feature we use was like in the application of automotive safety. Those are like in vehicles, like in modern vehicles now, you can see they have like the sensors that you can dictate like when there's an object on the side, and also we can use it like with proper braking, which can be able to dictate like when there's an object in front of the car, So this is like application of the HOG features. Then also we can use it like with vehicle dictation, like in the toll roads, you want to like in the state borders, you want to dictate the number of cars that are going through the borders, or you want to dictate the number of cars that are going through the toll. You can use like the HOG feature and some programming and some MATLAB code like we just did in our project, and you'll be able to like tell you the number of cars that are going out. And looking back into the video, you can see like a practical example of how HOV features are being used to classify like cars and to tell the number of cars that are going through a particular point in time. And also we can use that to classify other objects. It must not be like only vehicles. You can classify like pedestrians, vehicles, but whichever object you want to classify has to be like a sample in your X sample data point. And for the ones you don't want to classify, you don't want to see, it should be like a Y data point. Also in modern system, you can use that to read numbers from houses, like apartment numbers, building numbers, addresses. So all those are like applications of the HOV feature.
And as a summary of how this project presentation went, I believe this project helped us to learn more and better our understanding on HOG and some of its application in real life. So in addition to what we learned in class and also the assignment that we were given, this project helped us better more and learn more about HOG features. Also the fact that we were able to understand more how to apply MATLAB into HOG features, detecting objects and digits. And lastly, we had some bit of issues with our MATLAB code. We had errors while trying to run our MATLAB code, but in the end we were successful enough to get rid of these errors and had our MATLAB code working, and that's why we were able to produce the figures that we showed you in our slides.
Alright, so even though the program was like kind of challenging, but at the end we're all happy because we learned a little more insight on HOG features, and also we learned how we can use MATLAB to stimulate the various programs that we did, and at the end, we got a better understanding of the HOD feature which was taught in class, and also how we can use it in real life applications. And this takes us to the end of our presentation. I also want to take this moment out to say congratulations on your award, Professor. While working on our project yesterday, we saw this on campus, and we're proud to be your student, and we want to say congratulations on your award.
Yeah, we are so proud of you, and we aspire to be like you. Well, thank you for your hard work, and thank you for a great semester. That marks us to the end of our presentation. Thank you very much.